In section 4.4, we're going to talk about graphing parallel and perpendicular lines. So the key to graphing these is knowing the relationships of the slopes. So parallel lines have the same slopes. They have the same rise over run. So for example, let's say we have the equation y equals negative 1/3 x plus 1. If I wanted to graph this, I'm in slope-intercept form, so it'll be pretty straightforward. I have a y-intercept at 1, and then my slope is negative, so I'm going to go down 1 over 3. Once I have my 2 points, I can make my line. Now let's say I also want to graph the line y equals negative 1/3 x minus 2. Before even graphing this, I could look at the fact that these have the same slope and know that they're going to be parallel, but let's just graph it anyway to see how that looks. Here, I have a y-intercept at negative 2, and I'm still going to go down 1 over 3. When I graph this, I can clearly see here that these are parallel lines. On the other hand, perpendicular lines, their slopes are opposite reciprocals. Remember that perpendicular lines are going to meet at a right angle. What I mean by opposite reciprocal is I take my slope, I'm going to flip it, so flip that fraction, and I'm going to change the sign. So for example, let's say I had a slope of negative 2/3. The opposite reciprocal would be positive 3 over 2. And also that like upside down t is a symbol that we use to say perpendicular. So negative 2/3, that slope would be perpendicular to positive 3 over 2. Negative 4, I could look at as like negative 4 over 1. The opposite reciprocal there would be positive 1 over 4. And positive 1 over 3, that opposite reciprocal would be negative 3 over 1, or just negative 3. So for example, let's say I have the equation y equals 3x. I have a y-intercept at 0, and my rise over run is up 3 over 1. Plot my next point, and I have my line. The equation y equals negative 1/3 x minus 2 would be perpendicular for that. So I'm going to graph my line starting at negative 2 for my y-intercept. Now I'm going to go down 1 over 3. Plot my next point, and I have my line. So as you can see here, those two lines meet at a perfect right angle, so they're perpendicular. Now, a type of problem that you might see tomorrow or on like an upcoming test would be something like this. I have a diagram with some line drawn on there. I didn't necessarily give you the equation, but I want you to graph a line perpendicular to it. I don't really need an equation for this line. I just want to focus on the slope that I see. So I'm going to look and see like where I'm crossing at a perfect coordinate. For example, it looks like I'm crossing at 0, 1. And I'm going to count up and over until I get to the next coordinate. So to get to the next coordinate, it looks like I have to count up 2 over 1. So my original slope is positive 2 over 1, or just positive 2. So now from there, my perpendicular slope would be negative 1/2. Now when I'm going to graph this, it doesn't matter where I put my y-intercept at. Really all that matters is the slope here. I'm just going to put my y-intercept at 0, 1. Now I'm going to graph my line by going down 1 over 2. Make my next point and make my line, and as you can see here, these meet at a perfect right angle, so they're perpendicular.